several washing machines. So for example, in the first washing machine we have one dress, and in the second we have 0 dress, and in the third washing machine we have 5 dresses. So our target is that we're gonna try to move the dresses from one washing machine to its neighbors. So for example, this 5, its neighbor is this 0, so we can move one dress from 5 to 0. Yeah. So our target is that we need to get the equal dresses after move, but the move is only, but for the move can only be done to its neighbors. So for example, this 5 cannot move to this one directly. It has to move to 0 and 0 to 1. It must be, yes, it must be moved from the neighbors. And we can pass one dress of each washing machine to one of its adjacent washing machine at the same time. So this means we can also do it simultaneously. Yeah. So let's try to do it. So for example, from 5 to 0, yeah, we need one move. So here gonna be 1, and this is 1, and this gonna be 4, because this is a neighbor. 0 and 5 are neighbors. Now we want to move this 4 to this one. Yeah, because we can move from here to here simultaneously. So this means this gonna be 3, and here gonna be 1, and here gonna be 2. Yeah, so this gonna be the second step, the first, second step, and third step. So for the third step, we can move this one dress from here to here. So it's gonna be 2, 2, and 2. Yeah. So this is basically the description of the problem. So if you understand the problem, so we're gonna try to use some other examples. Maybe for this 0, 1, 5, you can get some intuitions. Maybe what about the minimum moves? Maybe this is 5, and we can calculate the average of all dresses. So for average of the dresses, it means the sum up all the values. 1 plus 0 plus 5, it is 6. 6 divided by 3, because we have 3 washing machines, so it's gonna be 2. Yeah. Maybe we can guess. Maybe 5 minus 2. Here gonna be we can use 0 minus 2 and 1 minus 2. We can use absolute of all those values. Maybe we can get the result. Yeah. So this is one of the possible ways to get the minimum value. So currently, if we use this kind of method, because this is very obvious. Yeah. So this means in this place, if I have too many clothes, definitely I need to move it out. So I don't care how can I move it out. I just need to check how many dresses I need to move out. So for this one, I have 5 dresses, and for average I need 2. So it means I need to move out 3. And here, this is 0. This means at this position, I need 2 more dresses. Yeah, so it's gonna be here minus 2. It means 2 more dresses. And here, at this position, for the average it is 2. Yeah, so from here it means I need 1 more dresses. Yeah, so this means I need to take out minus 3, I need 2, I need 1. Yeah, you know that the sum up of all those values also equal to 0. But definitely from this formula we can get the maximum value, so it is 3. Yeah, but this is not the result. Yeah, because this is only in the real. This is only for the situations. For each of the washing machines, we just need to move it directly. We passed only like maximum past 3 clothes. So what if at this position we pass 4 clothes? So the minimum value is not 3 anymore. Yeah, let's just try to use another example. Yeah, because for this example, for each of the washing machines, how many dresses passed? So at most, it's gonna be 3 dresses passed. Yeah, because for here, 5 becomes 2, it means we moved out 3 dresses. So it means we passed 3 dresses. And for here, this means we accept 2 dresses. Yeah, but how many dresses passed from this position? Definitely, it is 3. Yeah, because it accepted 2, it means I passed 2 dresses, and also I need to give 1 to this one. It means 3. Yeah, and here how many dresses passed? so it is 1. But for the maximum passed, it is 3. Yeah. So this means we also need to calculate another value. So the first value is we're gonna use this value, each of the numbers minus the average, and then we can check the maximum. Definitely we can get the a possible result. Another value is that we need to check how many dresses passed through each of the points. So at this position, 3 dresses passed. At this position, 3 dresses passed. At here, only 1 dress passed. Yeah. So it means the maximum of this 3 and this 3 gonna be the result. Let's try to use another example maybe. So for example, we have at the first washing machine we have 8 clothes, and the second we also have 8 clothes, and then we have 0 and 0. What are we gonna do? The first way is that we don't care how many dresses passed through each of the washing machine. We only need to check how many dresses I need to take out. So because the average value of the 4 numbers is gonna be 4. So for this washing machine, it means I need to take 4 dresses out, and this I need to take 4 dresses out. So this means it's gonna be a -4, -4. Here it means I need to accept 4. Here I accept 4. Yeah, you can say the maximum absolute value of those 4 numbers is gonna be 4. But this is not the result. Yeah, because you know at this position it means we have 4 more dresses. But when it comes to this position, it means we have 8 more dresses. Why? Because if I were to give all dresses to its neighbors, because the dress is moved through adjacent washing machines, yeah. So for this position, it means, yes. So for example, at this position, if I were to accept a dress, definitely I would to accept it from this washing machine. Yeah. But for this washing machine, how many dresses passed through? Because for me, at this position, I need to take out 4 dresses. Yeah. And also for this position, I need to give 4 dresses to this position. So this means at this position, maximum I need to pass, or I need to give 8 dresses out. Yeah. I don't care I give out to which washing machines, but at least at this position I need to give 8 dresses out. At this position at least I need to give 4 dresses out, and at this position at least I need to accept 4 dresses, and this position I need to accept 4 dresses. Yeah. So you know this is -8, this is -4. We're gonna check the maximum absolute value of -4 -8 for 4, so it's gonna be 8. So the final result would be this 4 and this 8. So it's gonna be 8. Yeah. So if you understand about the examples from here, normally we can solve the problem. Yeah. So we need to get the total value of the washing machines. So we're gonna use the sum of all the dresses inside the washing machines. So it's gonna be a total. And we also need to check how many washing machines do we have. So it's going to be length of the washing machines. Now we are going to check if this total modular this n equal to 0 or not. If it is not 0, definitely we're going to return a -1, because this is not possible, because we need to get the average of all the, we need to get an average value, which means in each washing machine we're gonna have this average value. Yeah. So if we have the average value, so we're gonna prepare an average. So it's gonna be the total divided by n. Now we have this average value. Yeah. Now we are going to check the washing machines one by one. So for m in machines. Yeah. But before that, we need to record a final result. It's gonna be the minimum washing machines. And I also need to define another variable, need. So this means if this need is a positive, it means I need more clothes. If this is a negative, it means I need to give out more clothes. Yeah. So from the beginning, the result and need gonna be 0. Now I need to check this need first. So for the need, I need to plus minus m. So this means let me use the maybe the first example for 1, 0, and 5. So for the first number it is 1, but the average is 2. So the need would be plus equal to let's use the average minus m. Yeah. Now let's just try to use this example. So from the beginning, this need is 0 and the average is 2. So for this average 2 in this example, yeah, average 2 minus m is 1. So the result is gonna be 1. Yeah. So currently the need is 1. So this means for this washing machine up to here, I need 1 dresses. I don't care. I will get it from which washing machines. It doesn't matter. But for me, it means I need at least 1 dress. So currently, for this need, I have a value of 1. Yeah. Now, I will move on to the next one. So for this one, so currently my need is 1, but at this place I need to check my need. So the average is 2. 2 minus this m0, it is 2. So this 1 plus 2, it is 3. It means up to here, I need to have 3 dresses. Why I need to have 3 dresses? Because I need to give 1 dress to this washing machine to make it a 2, and this also make it a 2. Yeah, it is not 2. Definitely, if it is only for me, I just need 2 dresses. But I need another 1 more dress. I need to give 1 more dress to my neighbor, to this one. Only in this way I can make the average value of 2. Yeah, so this means up to here, the need is 3. And then we're going to move to this one. This is 5 minus 2. It is minus 3. It is average 2 minus 5. It is minus 3. So minus 3 plus 3, it is 0. Yeah. So because when I go to this place, definitely I don't need anything. So this need gonna become 0. Yeah. So I'm gonna check the maximum of the need. But I also need to check the maximum of this value minus the average value too. Yeah. Now let me just finish the coding. So the result gonna be the maximum of the result with this absolute of need. Because this need can be a positive value, this means I need something. If it is a negative value, it means I need to give out something. And I also need to check the value. I think this the last one gonna be obvious as the absolute of this m minus the average. Yeah. So this gonna be the final solution. So because some of the cases we're not only to check this need, but we also need to give it out. So for example, let's just use another example. So for example, let's just use 8 0 and 0. Yeah, maybe this is not a good example, but let's just try. So for this one, it's not a good example. We have to use 9. Yeah, maybe 9 0 0. For the average value, we are sure it's gonna be 3. Yeah. So for the first step, this is 9, and we're gonna check the need. So the average value minus this m. So the average is gonna be 3 minus m, and it's gonna be minus 6. Yeah. As you can see, this is our need. This means for this value, definitely it's gonna be 6. Yeah, because for this washing machine, it's gonna pass through 6 clothes, 6 dresses. Yeah. And for some other testing cases, we don't need. This is not the maximum. This is not the maximum value, but we need to check this absolute of this m minus average. Why? Let's try to use another example. So for the second example, 0 3 and 0, what we're gonna do? If we only use this need method, yeah, so the need plus the average, so currently need is 0, so the average minus m, so this is the average minus m, so let's try to use this. Average is 1 in this example, minus m, m is 0, so up to here this is 1, because at this position I need one dress, and up to here this is average 1 minus m, it is minus 2. 1 plus minus 2, it is minus 1. It means at this position I need to give one dress out. Yeah, I don't care I give it out to which position, but definitely I need to give one out. And at this position my need gonna become 0, because at this position I don't need to do anything, because I've already accept one dress from here. Yeah. Now as you can see, the maximum of this value is gonna be 1, but the final result is gonna be 2. Yeah. So this is because we need also to check the maximum value. The maximum value should minus the average value. So if this 3 minus the average value 1, it means 2. It means at each position I have to give out 2 dresses. I don't care I will give it out to this position or this neighbors or doesn't matter. I just need to give it out to neighbors, but definitely at this position I need to give 2 dresses out. So this is why we have to check the absolute of m minus the average. Yeah. So if we solved basically the 2 formulas, definitely we solved the problem. Now let me submit it to check. Yeah, and the length of the array gonna be 10 to the power of 4. So this means, yeah, definitely for on time we can solve it. Maybe I need to copy it from other places. I think it is too slow. Yeah, definitely the networking is not so good. Yeah, but maybe yeah, definitely we cannot check it. Yeah, maybe I need to check it in another website, or yeah, let's just check it in another website. Yeah, it is not working. Let me just submit it to check again, to check if it is working. Yeah, let me check it in another place. Maybe it's gonna work. Yeah, so I used the same code, but just in another website. Let's just check if it works. Yeah, now as you can see it works. Now let me submit it to check if it can pass. There are some wrong answers. Let me check. Yeah, let me just delete this one. And submitted. Yeah, and here I cannot use the absolute value. Yeah, normally I think absolute is okay. Yeah, for this example, this is 10, 19, 29, 35. For average, it is 7. Yes, so if I use this one, it means from this position I need 6. This is why I output a 6. Yeah, but the idea is that if we use this need, we can get the maximum of the need, and from here we just need to give out how many clauses. So for example, from here we need to give out 3, and 3 gonna be the maximum. Yeah, and for this one, because the average value is 7, so this means at this position we can accept even 2 clauses at the same time, because we can accept 1 at the left side, we can accept 1 at the right side. Yeah, but definitely the final result is going to be the m, this value, minus the average. This means if I need to give it out, I need to check the maximum of the values I need to give it out. Yeah, but I don't need to check the maximum value to accept. So this means I don't need to use the absolute value. Because here, if I need to use absolute value, definitely I accept the clauses from left and right side, but I didn't take 2 steps. Only 1 step I accept 2 clauses. Yeah. So this is why while calculating this need, definitely, yeah, let's just use this example. So because the average is 7, so from here it means I need to give 2 clauses out. Yeah, and since I've already give 2 clauses out, let's just check. So the average is 7. 7 minus m minus 9, it is minus 2. So the need plus minus 2, it is minus 2. So from here it is minus 2. Yeah, so definitely it means I need to give 2 out. Yeah, and now from here, so this is average 7 minus m, it is 6, but 6 need 2 plus a minus 2. So from here, this value gonna become 4. Yeah, so it means at this position, I need to accept 4 more clauses. Yeah, it means I've already got a 3. 1 plus 2, I've already got a 3, but I need to accept 4 more clauses. Yeah, so I need to accept 4 more clauses from this 8. Yeah, definitely from this 8. But for this number 1, I can accept from the left side and the right side simultaneously. This is why I can save time. Instead of 6, I need to, yeah, because according to the question, we can pass through the addresses simultaneously to its neighbors. Yeah, so this means from this position, I have to use this m minus the average. I cannot use the absolute value. Yeah, so it means from here, the maximum is 4, and then up to here. But for this need, the maximum gonna be 4, and for the average, m minus average, the maximum gonna be 3. So this means I need to give out some clauses. Yeah, if I need to give it out, I can only give. If I give 1 clauses out, it means I will take 1 step. I need to take 1 time. Yeah, but if I were to accept the clauses, so for each of the step, I may accept 2 clauses, not only 1, as you can see from here. I accept 2 clauses. Yeah, so this is some mistake I I made. I should not use the absolute value. Now let's just try to submit it to prove it should. Okay. Now as you can see, it works. Thank you for watching. See you next time.